So we have a quiz tomorrow. The quiz tomorrow is going to cover lessons 11.4 and 11.5. The quiz is going to have 16 questions. Now, you may even have a few perfect squares, because I know it, I don't know if you realized, but yesterday when we did like the first example, it was actually a perfect square. So realize that some of these answers may be perfect squares and everything's going to come out of the square root. And then other questions, you may have to reduce the radical or simplify the radical. So for example, you might get perfect squares. So you might get a question like, find the square root of 25. And you're going to tell me it's 25. But you might get a question that's, find the square root of 75. And then this one is not a perfect square, so then you got to break it down. So you could either start with 5 times 15, 3 times 25, whatever you want to start with, and however you want to break it down. Now, if you're good at recognizing that 25 was a perfect square, you could go right to the answer. If not, you'd have to keep breaking this down until you get prime, and then until you can make a pair. The pair comes out, and then the radical stays, the other number that you cannot make a pair with stays underneath. Now, there are also going to be a few fractions and a few decimals, which we did in 11.3, just to make sure that you guys are remembering how to do these. So, for example, you might get a question like, for example, number from 11.3, 20 over 45. Notice these are both not perfect squares. So what we can do here is you could either break it down and pull out the perfect squares, or you could try to reduce the fraction first. So you could break it down into like a tree, 4 times 5, and here 9 times square root 5. These will cancel. These are both perfect squares, and then you get 2/3. Or you could simplify the fraction. So I could divide them both by 5 and get 4 over 9, and then find the roots separately. So you'll have fractions again. Again, you're going to have decimals again. So for example, if I have 0.04, first thing you should always do is count and make sure that the number of numbers behind the decimal point is even. This has 2 numbers behind it, so I can actually do it. So there's 2 numbers, 2 divided by 2. So I know there's going to be 1 number behind my decimal point in this answer. So I would square root the 4, and then that's my answer, because 1 number behind the point. Because 0.2 times 0.2 is 0.04. Now, if you had 0.004, you would see that there's 3 numbers behind the point. So you would tell me that this one is just the answer rewritten, because we can't do this problem without a calculator. So if there is an odd number behind the decimal point, then you just rewrite the problem. There has to be an even number of numbers behind this for you to work. Again, also remember, if you have a negative number under the root, you're going to tell me that this answer is no solution. So be able to do all of this type of problem. And again, you can have perfect squares on this. Now you might even get perfect squares where it's got variables with it. So you square root the number. So square root of 16 is 4. And then remember the variables, you divide their exponents by 2. So this would become an x squared and then a y to the first. Again, remember, if it's odd, you're going to break it down and make one of them even. So for example, if I gave you 25, x to the 7th, what you should do here is keep the 25. You could either factor this. You could do it like this. Square root of 25 is 5. Take the exponent that you've just made one less and make it even. x to the third, and then this x has to stay underneath because you can't divide it by 2 without getting a remainder. So be able to find square roots of variables. Also be able to factor like we did in the notes. So you might get a trinomial that you're going to have to factor. So I had done an example like that yesterday. In 11.5. So for example, this was example 1C. So you may get a trinomial that's under the radical that when you factor it, it turns into a binomial squared. So you have a pair of m minus 3's. So then one of them comes out. So you'll have some trinomials to factor. And then you'll also have questions from the bottom of tonight's homework, 27 through 50, where you're going to have to solve it. And remember, the answer is both the positive and the negative answer. So for example, if I give you x squared equals 25, you can either subtract the 25 and factor the difference of two squares, or just square root both sides. And this gives you x equals plus and minus 5. Now, you might also get a question that's going to look like this. 2x squared minus 5 equals 0, or minus 50. So here, what I would do is factor out a GCF first, divide everything by 2. Then it turns into the difference of two squares that you can factor. So this turns into x minus 5, x plus 5, and then you set each equal to 0. So again, this answer would be 5 and negative 5. Or you could move the 25 over and square root both sides. Either way. So be able to solve for x, and remember, those questions are going to have two answers. So you may have to factor out or divide a GCF first. This one could also be solved this way. 2x squared minus 50 equals 0. I could add the 50. 2x squared equals 50.
Magali Perez, please.
Divide by 2.
Your appointment's here. Magali Perez to the front.
X squared equals 25. And then this is where you could square root both sides. And x equals plus and minus 5. So either way. So 16 questions. If you've done the homework, it should be a nice and easy quiz. The questions on the quiz look very much like the homework questions. All right, so I'm going to go ahead and give you back now your old stuff, and we're going to go over those.